Everyone having a good PyCon so far? So I'm Vinayak. I'm going to talk about my project to run every street in Paris. And this is what the outline looks like. I'll talk about my motivation to do such a thing. We'll look at GIS and some related concepts, how we can get data from OpenStreetMaps, which is an open source mapping database, how we can store it in Postgres and PostGIS, and finally map match our runs to visualize the progress that we make while running a city. Hopefully that will give you an overview on how to build a system like this or like a similar system for your own city or even tackle problems similar to this one. A little bit about myself. I'm a software engineer based in Paris. I built a bunch of open source libraries, most notably Camelot, which is a PDF table extraction library, which has been used at places like NASA, Stripe, and Figma. You can check everything out at that link up there. I'm also part of the Recurse Center, which is a programming retreat in New York City, where you spend 6 or 12 weeks programming at the edge of your abilities. It just requires an investment of your own time and nothing else. So if you're in a position to do that, I'd highly recommend doing the retreat. If you have any questions about RC, you can chat to me about it later. So getting back to the main subject, how did I start thinking about running every street in Paris? A couple of years ago, I stumbled upon the PacTom project by Tom Murphy, where he ran the length of every street in Pittsburgh, which is around 2,400 kilometers in total, which would be maybe 1,800 miles. He finished the project in 2022, covering close to 6,000 kilometers in 269 runs across 2 decades. Then I started to look for other people doing similar things and found Ricky Gates, who did the same thing in San Francisco. By the way, if you have time, you should definitely check out this video that Tom Murphy made. It's really entertaining and has a lot of really cool data visualizations. So I started thinking if I could try running every street in Paris, because it's such a tiny city and it's very walkable. I moved here in 2021, and I'd been running the same loops over and over and thought it could be like a fun challenge to try and run every street in the city while also learning about GIS, which is another thing that I always wanted to look into. Tom Murphy and Ricky Gates had a bit of a manual approach where they were tracking their progress by hand, either on Google Earth or on paper. And I thought it could be a fun side project where I could automatically track my progress. So this is an approach that I came up with. Fetch OpenStreetMap data, fetch the street network for Paris from OpenStreetMap, compute the minimum number of 10K routes that would cover every street in Paris, because I only wanted to do 10K, which is like 6 miles, but at a time. Run them, and then automatically match my runs to the street network and visualize my progress. For those of you who are not familiar, OpenStreetMap is this open map database updated and maintained by a community all across the world. And it's very easy to fetch the street network for a city using a library called osmnx, which we'll look at a bit later. But calculating the minimum number of 10K paths that can cover every street in Paris turned out to be a bit challenging. I discovered that what I was trying to do is essentially a variation of the Chinese postman problem, where we need to come up with the shortest route that can cover every street in a road network. At this point, I was spending a lot of time wrestling with the data that I got from OSM and not spending a lot of time running, so I decided to tweak my approach a bit. I thought I can just draw these routes myself initially, build out the rest of the system to map match my runs and visualize the progress, and then eventually get back to computing routes automatically. And so I have it deployed on a server now, and whenever I run on Strava, it sends a webhook to my server, which updates the progress that I made in that run. So yeah, this is what it looks like. I have it all visualized on a map, and maybe I can show you a quick demo of what it looks like. You'll be able to find this link at the end of the talk, but you can see that I've covered most of the north of Paris. I still need to go to the south and go to this small hilly neighborhood in the north, which I'm going to do at the end. So let's get back to the slides. So before going into the implementation of this thing, let's take a step back and talk about GIS. Because what I've built is essentially a geographic information system. GIS is a framework for gathering, managing, and analyzing spatial data. And these systems are used everywhere, from urban planning to logistics, et cetera, et cetera. When working with spatial data, we need to understand coordinate systems. There's mainly two types: geographic coordinate systems, which use latitude and longitude, like the World Geodetic System 84, which is what our GPS uses. But then we have the projected coordinate systems, like that flatten the Earth onto a 2D plane, like the Mercator projection that you might remember from school. Each has trade-offs. Geographic systems are great for GPS, but projected systems are better when you need to calculate distances and areas more accurately. There are two main ways to represent spatial data. Vector data represents features as points, lines, and polygons. Think of it as drawing with geometric shapes on a 2D plane. On the other hand, raster data is like a grid of pixels, like an image. So vector data is perfect for discrete things like roads, buildings, or city boundaries, whereas raster data works great for elevation maps or temperature or satellite imagery. For my street running project, I'm mostly working with vector data. These are the basic building blocks of vector data. We have points which represent single locations. For example, the location of this conference center in latitude and longitude. Line strings are just paths or routes, which are just an extension of the point geometry. You basically connect multiple points to form a line string. And then polygons represent areas like parks, buildings, or even an entire city. So these are the fundamental geometries that I'm working with for this project. Which brings us to GPX. When we record a run using our GPS watch or a phone, the data gets saved in a format called GPX. It stands for GPS Exchange Format, and it's basically XML that stores the coordinates of your run. As you can see here, each track point has a latitude, longitude, elevation, and a timestamp. And this is the raw data that I get from my runs when I need to process and match the run against the street network. And you should be able to get these GPX files from most fitness apps like Strava or Garmin Connect or Apple Fitness. All of them export runs in this format. So now that we have all of this spatial data, where do we store it? That's where Postgres and PostGIS come in. Postgres is this incredibly powerful database that has been around forever. And PostGIS is an extension that turns this database into a fully fledged spatial database. It adds these data types that we just talked about earlier, so we can store points, lines, polygons directly in tables in Postgres. Plus, it gives us hundreds of spatial functions for things like calculating distances between 2 points, finding intersections, checking if a point is inside a polygon. You can do anything. So with these building blocks, let's start looking at some code. So I mentioned getting the street network from OpenStreetMap using this library. We are going to use osmnx. We import it. To get the street network for a city, you can just call the graph from place function like that, put in the city name, and choose the network type. In this case, we pick walk. But as you can see, it's pretty dense. If I zoom in, it just has a lot of nodes for the same intersections on the road and a lot of edges too, and it's just too complex to work with. So what we can do is change the network type to drive, and it looks a bit more workable. But if I zoom in to this station here, we see that there's a street, but it's not available because the car can't go there, but I can probably walk there. So I'd want to get that street. And so when I was trying to sort of figure out how to get all of these streets where I could walk, but a car couldn't go there, I found out that OSM has a way for you to filter the data that you get from it. And I found this repo where someone had already created this custom filter, and it looks really complex, but it's basically removing all the tolls, giving you all the highways that are residential, and a lot of those different things. And what we can then do is put that custom filter into this custom filter keyword argument to the same function, and we get the street network, which is a bit more workable. And if we zoom into this station here, we can see that we got the street that we wanted. We still don't have this street, but that's fine because it's sort of like a gated neighborhood, and I can't really go into a gated neighborhood unless I have access. And I'm not going to break any laws to finish this project of mine, so I'll let that go. After that, we can convert the graph that we got into a geodata frame. And to do that, We just use the graph2GDS functions, set edges to true because we don't really care about the nodes. And if we do a dot head on that geodata frame, we can see that we have a list of streets. Each street has an OSM ID, which is a unique ID OpenStreetMap gives to a street or any sort of geometry. We can see the highway type, we can see the number of lanes, the max speed, the name, but most importantly, the geometry, which is the line string that is connecting two of these Latin long points. And so like with any data project, there's some data cleaning to be done. A bunch of those street names are nans, and a bunch of those street names are lists. So for the sake of not having nans in my database, I just set it to unnamed street with a unique number at the end of it. And after we do that, we can see that there's no nans or lists anymore. But then we get to one more thing, which is OpenStreetMap can give you these streets as separate segments. So each street could have like different line strings available in the same geodata frame. And what we need to do to get around it is use this dissolve function. You can think of it as a group by. If you have used SQL before, we are basically grouping by name and combining all of those street geometries into one by using this dissolve function. And once we dissolve those streets in the geodata frame, which means combine them, we're going to see that there's no duplicates anymore. All of those streets are unique, and all of their geometries have been combined. At this point, the data looks pretty good, so we can start inserting it into Postgres. I already have like a Postgres server running locally. I've already enabled the PostGIS extension. And now we create this street model, which is tied to the streets table. We're just giving it an ID, a unique ID for the street name, a name for the street, and most importantly, the geometry, where we're going to store the line string for that street. We can insert it like that in a for loop with the data that we cleaned just before. And when we query the street table using session.query_street.all, we can see that we now have around 5,400 streets for Paris in our database, which brings us to our runs. So I did a short run, and I exported the GPX file for that run. And how you can read GPX files in Python is by using this GPX-Py library. And it gives you all the points that you covered across your run in this format. You can basically iterate on the tracks, the segments, and the points, and create this list of all the latitude and longitudes that you've been on. If I visualize it on a map, you can see that it's everywhere, like the points lie on buildings. And that's because GPS is not that accurate when you're running within a city. And that's where we're going to use map matching to sort of find the nearest point on the street to the point that we ran on, actually. Yeah, this is because of inaccuracy. I didn't really jump on those buildings. I wish I could, but I can't. Before we get into map matching, what we're going to do is interpolation. So if you look at this run, it's very sparse. If you imagine that there were no points here, when we would do the actual map matching, if this was the last point on that street, we would only match this part of the street. And so to get around this sparseness in our data, we need to just add a bunch of points all along the run, so that when we get here, we basically have some points to match on, and we get the actual street that we ran on. And so we make the data more dense. And to do that, I'm just adding 100, or actually 1,000 points at equal distances across my run, using the code shown here. If I display the run now, you can see that it's more dense. So when we do the actual map matching, it's going to work much better. We are going to actually cover like the whole street, which we're just going to see in a bit. This is the code that I had before. We have Postgres, we have our streets table, we have around 5,400 streets in the table, which brings us to the gist of the map matching. So we iterate on the run points list that we created earlier, and we run this query to find the nearest street. And what we are basically doing is querying the streets table, ordering by the distance between the point of our run and the street in that table, and picking the first street. and that is giving us the nearest street that we ran on. If we can find the nearest street, we initialize this dictionary with the name of the street, and it's not visible here, but we basically have a points array that is being initialized here as an empty array, as an empty list. And what we're going to do after that is project our run point to the point on the street. So if I go back to this slide real quick, you can think of it as drawing a perpendicular line from this point here to the street, and that is basically projecting that point to the nearest street. And when we do that projection, we'll be able to find the point that we ran on that street. And so if we go back here real quick, we do that projection for every point across our run points array. And if we go to the next slide, you'll be able to see that we have two streets that we ran on. If I display them now, it looks much cleaner. Isn't that pretty cool? We were able to get the inaccurate GB extract to match on the exact points that we might have run on the street. And once we have those points, we can start maybe creating like a new covered streets table. It looks a lot like the streets table that we have already, named geometry ID, but we are going to store an additional thing called progress percentage. We iterate on the projected points dictionary that we created earlier. We create a line string out of those points, which means that we're just combining all of those points into a line string, sort of moving them to a higher geometry, and we store them like this. We just put the street name that we ran on, the geometry that we covered, and to calculate the progress, we just divide the length of the covered line string by the length of the line string of the street, and that gives us the progress on both of those streets. So on the first one, we ran around 30%, the second one, 95%, and as you can see here, it's pretty true, because this street here, it extends from here to here, and we run around only 30% of it, but this one, we've covered all of it. So now we can run queries like this one, where we query the covered street table and filter by the progress percentage on the table. And we can see that we've only covered one street more than 90% and haven't covered the other one. Which brings us to the second step. So what happens when we do another run? We need to basically update existing covered streets while also inserting new covered streets. It's sort of like an absurd in database terminology where we're updating and inserting new data. So I did another run, still not jumping across buildings, it's just inaccurate. We do the interpolation like before and get like a denser GP extract. We do like the similar nearest street map matching to find the street that we ran on. And find that we ran on the second part of the same street from earlier. And as we can see, it's much more cleaner after the matching that we did. And this is where we're uploading that new segment into the database. And it looks a lot like the code from before, except for one thing where we check in the covered streets table if we've run on the street already or not. If we have, we combine the existing line string of the street with the new run line string that we just created and store the combined line string into the table. And so here we are updating the progress percentage again of the combined line by calculating the progress by dividing the combined line string's length by the street line string's length. It's a bit of a tongue twister. And if we now visualize all of the streets that we ran on, we can see that we ran that street and we ran around 60% of the street. And if we do the same query again, it'll still return one street because we haven't run 90% of the second street, which is true. And this is where I'm just showing how we ran 95% of the curved street and 65% of the second one. I think that's all of the code that I had to show today, which means that we can get back to our slides. This sort of brings us to the end of the talk. I just wanted to say before ending that it's been super fun to run every street in Paris and explore new neighborhoods because I'm from Delhi and I can't think of doing the same there because the city is just so big. I tried to download the OpenStreetMap street network of Delhi, put it in a database, but it just crashed my browser when I was trying to load all of the streets because the sum of length of all streets for Delhi was around 500,000 kilometers, whereas in Paris, it's just 1,500 kilometers. So it's a very tiny city. I would recommend you visit it. And if you're there, ping me and we'll run together. So future work. So this simple approach has some trade-offs. Like when I run through a star intersection, it'll match parts of the street that I didn't run on. For example, I can go to this image, and this is the famous Arc de Triomphe in Paris. If you imagine that I started running on this street here, and then ran along the circle and went on that street, because of the nearest street heuristic that we came up with, I'm going to match some part of the street, which is not optimal, but it's a trade-off that I'm willing to work with for now, because I won't mark that street as completed anyway until I do 90% of it. So let's go back to the slides. But I started reading, and I found that there's this algorithm called the Viterbi algorithm, which uses hidden Markov models to find the most likely paths on a route. And so that could be something to try out. I also want to get back to computing those minimum number of 10K routes. So if any of you have any recommendations on how I should be doing that, like reach out to me afterwards. And hopefully I can have full coverage this year because I'm already at 60% and I should probably be able to finish it. And that was mostly it. You can find all the code, all the slides on this QR code. It should lead to the GitHub repo. And I believe we might have time for some questions.
Question. For the query where you have to go through all the streets and figure out what the nearest one is, did you think about using a spatial data structure so you don't have to go through every single street in that query?
Not yet, but that's like something that I would love to try. Yeah, if you have time to stick around after, like, let's just chat.
Oh, sure, yeah.
Hi. When do you think your app will come out and the whole world will race to cover all the streets?
Not sure yet, but like, yeah, some of my friends want to try it, and I might just put it up online so that people can try it, because yeah, I would love to get feedback on how to improve it.
Thank you.
Thank you, Vinayak, for your presentation. I am interested in this topic because, well, I'm from Mexico. I did some work for political purposes in which I was reviewing the data from all the electoral sections in Mexico. That's why I'm interested in what you're doing. So my question is, you did this for the running. It's like a sport approach. But have you been interested in use this knowledge in other purposes, for example, defining where are some real interest in real estate to invest, for example, or for example, the political interest, no, in some places in order to do political work, or I don't know, if, for example, you have some interest in visiting some specific sites within a city, to visit, for example, archaeological places or museums, I don't know, just in order to use all of these. And well, my question is because I would like to be in touch with you, because I have not been working with these technologies of GPS and ArcGIS and all of that. But I am very interested in doing this kind of work and, well, do some kind of evangelization in Mexico in these things also.
Awesome. Yeah, I didn't get that far, like, to predict, like, property prices or even, like, sort of figure out what the best landmarks are in a city. But, yeah, maybe that's sort of like an extension of the project where maybe as I run, and maybe as more people run their cities, maybe there's a way for them to like log things of like which was a good neighborhood to run in, for example. But yeah, let's chat about it. Afterwards.
And I think another thing, well, when you are driving your car, you do not have the same feeling and the same approach that when you are walking, no?
Yeah,
Because
yeah.
you are smelling, seeing, watching the people. You have another perspective. So I think in this case, it's a very good approach because you can even do some kind of, I don't know, like a YouTuber and show some insights in some areas of the city.
Yeah,
But, well, I will talk to you about that.
I actually got a GoPro and like I want to do like a running video so I can maybe try and record some of these neighborhoods as I run in them.
Yeah. You can put something with, for example, food and things like that.
Yeah.
Thank you.
Great talk, thanks. So based on the name of OpenStreetMaps, I'm assuming that most of their information is focused on just streets. Are you aware of any data sets that could help map out off-road things like, you know, trails for hiking, mountain biking, that kind of stuff?
I'm not sure, to be honest, but I think OpenStreetMaps, if I'm not wrong, they might have some trail data too. But yeah, from the top of my head, I don't really know of any other data sets that are open that might also have trails and everything.
Interesting. Do you see, like, do you think that the same approaches that you took could be, you know, applicable across, like, trails as well? Was there anything that, while you were working on it, sort of like, you know, was really truly specific to urban environments, or did you feel like the same techniques could apply all over?
So what I described was like a very simple approach, and I've only tested it in Paris. Maybe if I start running in like New York, I might discover edge cases where that approach might not work. So yeah, it could be a good start, but I would love maybe sort of recommend that you try it and then see if it works, and then like update it based on that.
Awesome. Yeah, thanks so much.
Hello. Sort of a two-part question. I know a lot of people use Strava to write something or make a figure. Anything you've tried of, you know, like a phrase or a figure added to the map? And then the second question I have lost, so I will wait for that answer.
So getting back to Tom Murphy's YouTube video, like he did all of Pittsburgh, and I would recommend that you watch it. He has like a bunch of data visualizations that he did at the end of the project, and I want to do something similar once I finish it. So yeah, like you can just keep in touch with me, and once I have that, I'll reach out to you. But I haven't really thought about doing any sort of street art, but that could probably be another thing that I could try.
And I did remember the second one. What about finding like the route that you could run the fastest because there's the most downhill, or the nicest? I don't know if microclimates are something that you could get, but maybe characterizing the routes within a city.
I think Strava is doing a good job of doing that already, so I don't really want to get into that because the runs that I do, I'm also like stopping quite a lot, and I'm not sure if the data that I have based on my runs, it will be optimal enough to figure out what's the fastest street to run on. But yeah, maybe like altitude, comparing altitudes between different points of a line string of a street, maybe that could be a way to figure out if that street is something that you could run really fast. But yeah, I'm not sure if I'll do it as part of my project. But yeah, let's hack on it if you want.
Hi there. Great project. Very cool. I was curious. Yeah, sorry, there's another mic. Gotcha. So do you get the GPX file straight from Strava?
Yeah.
Okay. Are there any other like formats they can export to? Like they don't do like shapefile or file GDB or anything like that, do they?
I think they might do .kml, which is, I think, the Google Earth format.
Okay.
I think they do TCX, but I haven't really looked deeply into what that means. I think I just use GPX because even before all of this project, even before this project, I would create GPX files and like put them on my watch so I could look at the map when I was running or going on a trail. But yeah, I think they export to other formats.
Okay, interesting. Because I was wondering if there was another form of data collection you're thinking about using, because then you could actually do what other people were talking about and mark down like specific landmarks if you make a feature layer on the side too. But if you're just doing the GPS data, then I think GPX makes a lot of sense. But have you ever considered like another form of data collection out on these runs aside from just getting it from Strava, or no?
Not yet, but yeah, that could be another cool thing to sort of figure out, like if it can start importing data from like maybe Apple Fitness or maybe other fitness apps too.
Yeah. Cool. Thank you.
Thank you.
Thanks for the talk. This is quite inspiring, actually. I have very similar question as him. I've been using Garmin Connect, for example, quite often, and I do running and stuff. I'm just curious, like, have you ever done any kind of investigation in one, how to automate the data that can be gathered through these apps and automatically upload to your database or something, and two, like how this existing softwares are already mapping your data. For example, when I open Garmin Connect app, I can visualize the track immediately after my run, right? There must be some kind of like mapping algorithm over there. I'm just kind of interested in, have you done any investigation in, if there's any things that you don't have to double dipping over here?
I didn't get the first question.
So the first question is like, what is your recommended way of automate the data gathering process? Like, after you get the data from Garmin Connect, for example, how do you automate?
I guess the way I've automated it is the web app is running in a server. I have like an endpoint that is configured with Strava. So whenever I finish a run, Strava hits that webhook to that endpoint, and like it just triggers the whole process like a background job to like map match like the whole logic that we talked about, and that's the way I've automated it. Did that answer your question?
Yeah, it did. And the second one was basically just like whether there is any existing algorithm, from the Garmin's, for example, that you can borrow from or whatever,
Okay. Yeah, I didn't really look deeply into that. I was always curious why Strava doesn't match your run exactly, because if you look at your Strava track, it has a lot of inaccuracies, and I wanted to just match like the exact street that I ran on. But I think all of those algorithms are proprietary, so you don't really know how they work, even if they do the matching. So yeah, I haven't really looked deeply into that.
All right, thank you.
Thank you. I think we have had all the questions.